Hello, my dear students. Let us continue with the next factor, that is spillway size and location. Okay, the safe discharge of flood water through dam is very essential, and for that, a suitable site for spillway should be available. If the area is such that a large spillway capacity is required, an overflow concrete gravity dam should be preferred where a small spillway capacity is required and where separate site for spillway location is available and earth dam may be preferred where large discharges are to be derived during the construction of a dam. A concrete gravity dam is preferred to an earth dam. If no other site is available for spillway, it has to be accommodated with the main dam across the main river section. In that case, a concrete gravity dam having overflow section in its middle would be a better choice, though an earth dam can also be constructed with central overflow section of concrete. Okay, next point is the factor is roadway. If a roadway is to be passed over the top of the dam, an earth dam or gravity dam would be preferred. Next factor is length and height of dam. If the length of the dam is very long and its height is low, an earth dam would be a better choice. If the length is small but height is more, gravity dam is preferred. Life of dam. Concrete or masonry gravity dams have very long life. Earth and rockfill dams have intermediate life. However, timber dams are adopted only for temporary storage. So these are the factors which affects the selection of a type of a dam. Now next let us discuss about the selection of a good site for the various types of dam. So there are various factors like foundations, topography, site for spillway, materials and reservoir and catchment area, communication and locality. Let us discuss about one by one. The first one is foundations. Suitable foundations should be available at the site selected for a particular type of dam. For gravity dams, sound rock is essential. For earth dams, any type of foundation is suitable with proper treatment. In general, however, the foundation should be free from seams, open pockets or fault planes. Formation in which hard and soft layers alternate are not generally good because the penetration of water may weaken the soft layers and lead to movement along them. Alternations of sand, stones and shales may also lead to slipping during excavation of the trench. Beds which dip gently upstream and strike across the valley provide probably the best foundation conditions among sedimentary rocks, as the resultant of the weight of the dam and water pressure will then act nearly at right angles to the bedding planes of the strata. No dam should be built across a fault known to have been active in recent times. The best conditions are when a dam can be built on one uniform formation. If more than one kind of rock is present in the foundation, different building strengths lead to differential settlements of the structure. Next point is topography. Uh, the river cross section at the dam site should preferably have a narrow gorge to reduce the length of the dam. However, the gorge should open out upstream to provide large basin for a reservoir. A major portion of the dam should preferably be on high ground, as this would reduce the cost and facilitate the drainage. Next point is site for spillway. Good site for the A good site for the location of a separate spillway is essential, especially in the case of earth or rockfill dam. However, in the case of gravity dam, a spillway may be located at its middle. The best site for dam may be considered to be one where the deep gorge and a flank at its sides are separated by a hillock higher than the height of the dam. In that case, the main dam may be located in the deep gorge, while the spillway can be located in the flank. Next point is materials. Materials required for a particular type of dam should be available nearby without requiring much of transportation. This would very much reduce the cost of construction. The next point is a reservoir and catchment area. The site should ensure adequate storage capacity of reservoir basin at a minimum cost. The cost of land and property submerged in the water spread area should be minimum. The reservoir site should be such that quantity of leakage through its side and bed is minimum. Reservoir site having the presence of higher permeable rocks reduce the water tightness of the reservoir. The geological conditions of the catchment area should be such that percolation losses are minimum and maximum runoff is obtained. The reservoir site should be such that it avoids or excludes water from those tributaries which carry a high percentage of silt in water. The site should be such that a deep reservoir is formed. A deep reservoir is preferable to shallow one because of lower cost of land submerged per unit of capacity, less evaporation losses because of reduction in the water spread area, and less likelihood of weed growth. Next point is communication. It would be preferable to select a site which is connected by a road or rail link or can be conveniently connected to the site for transportation of cement, labor, machinery, food and other equipment. The last point is locality. The surroundings near the site should preferably be healthy and free of mosquitoes, etc. as labor and staff colonies have to be constructed near the site. So these are some of the points you have to consider for the selection of the site for the dam. Okay, now let us discuss about the next point, that is the forces acting on gravity dam. So there are different forces which acts on the dam. The first one is water pressure, second one is weight of the dam, third one is uplift pressure, and fourth one is pressure due to earthquake, and next is ice pressure and wave pressure and sail pressure and wind pressure. So now let us discuss one. Okay, can see here all pressures are shown in one single diagram. Here this is a wave pressure and this is water pressure diagram. This is water pressure diagram and silt pressure diagram. This is silt pressure and this is a hydrodynamic pressure diagram, and uplift pressure. This is a uplift pressure. This is drainage gallery. This is a body of the dam. Okay, tail water pressure diagram. Okay, now let us discuss the first one, that is water pressure. This is the major external force acting on a dam. When the upstream face of the dam is vertical, the water pressure acts horizontally. The intensity of pressure varies triangularly with a zero intensity at the water surface to a value WH at any depth H below water surface. When the upstream phase is partly vertical and partly inclined, the resultant water pressure can be resolved into two components. Horizontal component PWH, and the first component is horizontal component and second component is vertical component, that is PWV, due to the weight of water supported by the inclined phase. Okay. Thus, horizontal force PWH, that is equal to WH squared divided by 2, which acts at a height of h by 3 from the base of the dam. You can see here, which is this is the water pressure, which is acting at a height of h by 3 from the base of the dam. This is a vertical force. This is a horizontal force. Vertical component PWV is weight of water acting at the CG of the area. If there is tailwater of height h dash on the downstream side, then it exerts both horizontal pressure PWH dash as well as vertical pressure PWV dash. You can see here. Here also it is there, this portion, tailwater portion. Thus, the horizontal pressure PWH dash is equal to WH squared divided by 2. And vertical pressure PWV dash is weight of water. You can see here. Okay. Horizontal force or pressure half into WH square divided half into W is here, it is written as gamma W. Okay, WH square divided by 2, which is acting at a height of h by 3. Unit weight of water, gamma W is unit weight of water. This you have studied in geotechnical engineering, the portion earth pressure. And this is height, gamma W into H. Okay. This is a vertical force or vertical pressure, and this is tailwater pressure, which exerts both horizontal as well as vertical pressure. Vertical pressure, horizontal pressure. Next force is weight of the dam. The weight of the dam is the major resisting force. For analysis purposes, generally unit length of the dam is considered. The cross-section of the dam may be divided into several triangles and rectangles, and the weights W1, W2, W3, etc. of each of these may be computed conveniently along with the determination of their lines of action. The total weight W of the dam acts at the CG of its section. The weight is equal to volume per unit length into density of material. You can see here, this is the weight of the dam total W, that is equal to W1 plus W2 plus W3. That weight is equal to volume per unit length into density of material. The next one is uplift pressure. The uplift pressure is defined as the upward pressure of water as it flows or seeps through the body of the dam or its foundation. A portion of the weight of the dam will be supported on the upward pressure of water. Hence, net foundation reaction due to vertical force will reduce. Water has a tendency to seep through the pores and fissures of the foundation material. It also seeps through the joints between the body of the dam and its foundation at the base and through the pores of the material in the body of the dam. The seeping water exerts pressure and must be accounted for in the stability calculations. I think all of you